Hello and welcome back. So far we have actually taken the data set, right? But for multiple linear regression we have taken the data set, then splitted data, random split into train test, and then using describe method we found one issue, the quality issue, we fixed it. And then we tried to look at whether there are nulls in the columns or not, and then using statistical approaches we fixed it. A little bit of business also took into consideration there, like 16 years and grad are kind of related, and the modes in the both columns are kind of similar. So we actually kind of looked into some business also and then fixed the two columns, and rest of the columns we fixed with mode only because not much time to analyze there, right? So now let us try to fix the categorical columns. To make the model understand data, we need to fix nulls, we need to fix quality issues, we may have to create new columns. We did not do that, but we have to definitely convert the categorical columns into numbers. The text columns are categorical columns into numbers. So what is the difference between text column and categorical column? In a text column you will have general text, natural language, you will have a user review on a product, or description about the employee can be a text column because there will be different words, right? But a categorical column will have discrete number of categories, like designation has got only 7 categories, the qualification has got only 3 or 4, degree has got only 3 or 4, like that. So when you can count the distinct values in a particular text column or the string column, that's called as categorical column. The categories, right, can decide the target variable, the salary. So to analyze and understand whether a particular categorical column is having strong relationship with the target variable or not, we need to do ANOVA test. Here we are not doing ANOVA test because we are trying to understand the total end-to-end process of building a data science project or data science module, right? So we'll see that in a separate session. Let us focus on how to convert the categorical column to numbers without doing any inferential statistical analysis. We are just converting the categorical column to numbers in another way, right? If you have in designation, right, in the designation column, if you have 7 categories, we are assigning 0 to director, 1 to junior developer, 2 to senior developer, 3 to manager. Wherever we find director, we will replace with 0. Wherever we find junior developer, we will replace with 1. Wherever we find the developer, senior developer, will replace with 2. Like that we are going to convert. That's called as label encoding. We are converting our categories into numbers. We are assigning one number to each category. Wherever that category comes, we are going to replace it with that number. So for an example, what I did is how to do label encoding, right? It's called as label encoding. How to do label encoding? I have copied the designation column and then converted that copied column into a categorical column, right? In data frame there is a method, there is a class called categorical, which actually converts the data type of the column to categorical, which actually gives a powerful methods or attributes to convert the categories into numbers, right? We are doing label encoding here. We'll do one hot encoding in the other session where we do the statistical data analysis and the ANOVA test and then do, right? But here, for example, we are taking the designation column, a copy, right, to how to perform the label encoding, and then we converted that column to a categorical column. To convert a column into categorical column, you need to pass the column. At the same time, we need to pass all the categories present in the column. Why do you need to do this? Is in real-time applications, there will be drop downs, right? There will be in a mobile application or a web application, there will be drop downs which will have values, different values. So in this example, if you have to say, maybe the category senior director is already there in the employees database or the application, but there is no senior director in the data set or the organization. What will happen? That in the train set you will not get that category. The other categories will be there, and you may assign numbers to them, But in future, if you get senior director, the model will fail because there is no number assigned to that senior director. So whatever allowed values for that particular column are there, you need to pass them as categories so that the categorical class will assign number to it and keep it aside. When you convert, it will actually use that number to convert the actual values, right? So here the categories available in this data set are, allowed values in this application are 7. We have passed all those values here and converted our column into a categorical column. And then if you say cat dot categories, right, it will give you all the categories. And if you say cat dot codes, it will give you the codes assigned to it. Or you can actually enumerate the categorical column. This is a categorical column because we converted it using pd dot categories. And then say cat dot categories, right, it will have the code and the category assigned to it. Let us try to execute these statements. Right? We can see the director is assigned with 0, junior developer is assigned with 1, senior developer is assigned with 2, like that. So when you say the designation copy is equal to train set dot cat dot codes, right? All the codes assigned to it, if I try to look at this cat dot codes, it's actually showing you for every index whatever the code it assigned. So on the left side we have got the original column, right? Original column with the names, the categories, and on the right side we have got the codes assigned to it with indexes. But when index matches, right, it's going to overwrite the values in the original column. So this is how we actually convert a categorical column to numbers. If I say value counts now, I did not execute this statement. If I see value counts now, I'll get the number assigned to the category and the count there instead of category. This is how we convert a categorical column to numbers. For example, I have done it, right? So to explain you how to convert a categorical column to numbers, I have taken a copy and did this all exercise. So I am dropping the column because I don't need it. Okay. So I have written a method to automatically dynamically replace all the categorical columns to numbers. To do that, what I did is I took a dictionary with the category name and all the allowed values in there, because while converting your column to categorical, you need to pass the series object and then allowed categories, right? So I have created a dictionary with category column name and the allowed categories. Again, column name, allowed categories, column name, allowed categories. So in the loop, when I get the column, I'll actually pass the categories, allowed categories, from extracting from the dictionary. So if you look at this loop, I passed all the columns here and the data frame. It can be train set or test set. Okay. So I passed, suppose that I passed train set, and all the columns are there. I am looping through. The first column I have got, maybe it is designation, and then I am taking the data frame of designation, I am replacing it with categorical column of designation, and allowed categories are from this dictionary. I am bringing the allowed category. Dictionary of key will get me the values or the value. That's a list. So I passed the list of values allowed for the designation, and then I am actually replacing the designation with the cat dot codes. That means all the values, numeric categorical values, will be replaced with number. The next is qualification. You get qualification into column, and here I am converting. I am actually taking the series object of qualification, and then categories I am pulling out from the dictionary. In this dictionary, what is there in the qualification? I've got a list. I am putting it here. So categories attribute expects the allowed values in that particular column so that it can assign numbers to those categories. Once it assigns those numbers, right, we can actually say cat.codes and replace the original values. Like that, in a loop, I can fix all categorical columns in a single shot. So I created this method here, right, and let me execute this. And I created the dictionary. Now I created the method. I am calling that method by saying train set dot select a D type object. That means what? It will give you only the object data type columns. Let me show you that. So object data type is nothing but the string, the categorical columns, and then I said columns, right? All the columns which have got categories, and then values, right? Only the list, right? The list the numpy array I am passing, and the train set I passed here. Okay, so that actually fixes all the categorical columns in a single shot in a loop. So let me execute the statement. emp hash I have dropped somewhere. Yeah, here I did not execute this statement. So I dropped employee number because employee number is not useful in predicting because it's a sequential number. So I dropped it and now it is working. So the select D types I took only the categorical columns and column names I passed into this, and the train set I passed here, and it fixed all the categorical columns into numbers. Now if you see, right, all the data types are either integer or float. Now the data set is ready, right? So let us try to look at whether there is multi-collinearity or not. What is multi-collinearity? More than two columns have got correlation. So that can be checked with a heat map, right? So all columns are now numerical. So I'm just trying to generate a heat map and see how it looks like. If you look at it, there are no red areas in the lower triangular matrix. Here, the heat map generated, the lower triangular matrix and upper triangular matrix are same, and the diagonal values are the correlation between the feature and itself. If you see, designation and designation is 1, experience and experience is 1, salary and salary is 1, because correlation, right? When the one is increasing, the other is also increasing, it's going to be 1. One is increasing, other is decreasing, it's going to be -1. The scale also is chosen between -1 and +1. If you look at this code and play with this, right, you will understand more. We have shown it before also, right? So here, if you look at it, there is no strong correlation between two columns. Only salary and experience, designation and band, we have got correlation. That too, it is not 1. There is some correlation, right? But it is not too strong, like 1 or -1. So I think there is no much multi-collinearity problem here. Even if multi-collinearity is there, in predictive power it's not going to affect. Only the effect is that it's going to add lots of weight on the memory and processing. Okay, so the problem is not there. So the data set is good to go because we converted all the columns to numbers. We fixed the problems. So in the next session, let us build a model and see how it's working on train set and test set. Thank you.